To solve the supply problem of NVIDIA's GB200 chip, the market rumors that NVIDIA will introduce fan-out panel-level packaging technology ahead of schedule. With a tight supply chain, could fan-out panel-level packaging become the new savior for tight AI chip capacity? Before explaining what fan-out panel-level packaging is, let's first understand the difference between traditional and wafer-level packaging. First, in traditional packaging, the wafer is cut into chips and then packaged. As for wafer-level packaging, the wafer is packaged first and then cut. The size will also be smaller than traditional packaging. However, the substrate area for wafer-level packaging is limited due to equipment size constraints. Thus, fan-out panel-level packaging came into being. The full name of wafer-level packaging is actually fan-out wafer-level packaging. The difference between it and FOPL is only P versus W. Both have high I/O density and thinner designs, but the main difference is in size and utilization. Their common point is fan-out. Packaging technology can be divided into fan-out and fan-in, which are roughly the same in terms of process. The biggest difference lies in the redistribution layer, a metal copper connection trace that can be understood as part of the chip's wiring design. In fan-in packaging, the RDL can only accommodate about 200 I/Os for inward wiring. In fan-out packaging, the RDL can wire inward and outward, achieving more I/Os and higher transistor density. The earliest fan-out packaging was proposed by Infineon in 2004, known as fan-out wafer-level packaging. Mass production began in 2009. However, FOWL's exclusive focus on mobile baseband chips led to rapid market saturation. TSMC's implementation of integrated fan-out, or INFO, for Apple's A10 processor in 2016 catalyzed the industry's acceleration of FOWLP technologies. However, FOWLP's inherent limitations in area utilization and cost effectiveness, stemming from low die per wafer yields, ultimately drove the development of its successor, fan-out panel-level packaging, or FOPLP. Fan-out panel-level packaging, or FOPL, combines fan-out packaging with panel-level packaging. FOPL is an extension of FOWLP. Its advantage over wafer and traditional packaging is its larger rectangular substrate, which greatly increases wafer utilization and provides more space for heterogeneous integration. According to panel manufacturer Innolux, an FOPL substrate of 700mm by 700mm can hold about 7 12-inch wafers, achieving a utilization rate of up to 95%. Its massive output potential attracts major manufacturers like NVIDIA and AMD. Finally, some equipment manufacturers admit that the key to FOPL at this stage is the equipment. Substrate and panel-level packaging technologies are still far from mass production. Although used in automotive and communication chips, many technical limitations remain for AI or high-end server processor packaging processes. The industry also believes that in high-speed computing, CoWoS will remain mainstream for the next 3 to 5 years. Therefore, whether FOPL can become another key tool for advanced packaging remains to be seen. It will depend on chip manufacturers' product positioning, yield issues from factors like warpage, and overall performance and price, which will be key to customer adoption.